Okay, hello, my name is Dan McFinsky. This is my first video tutorial, and what I'm hoping to do here is teach people a little bit about the Unity UI system. As you can see here, I have Unity open, um, and I have a project where I've created a calculator in Unity using the Unity UI system completely. Now this calculator does work. It's not the greatest calculator in the world, but it does do some simple arithmetic. You can see 6, well, that's not going to work actually. This is a problem here, 6 and 5. 6 minus 5 equals 1. 2 minus 9 is -7. 9 times 6 is 54. Great. So you can see this calculator here has some really basic functionality. It scales with the window here, which is kind of nice. And it's all done in 2D. So if you look here in the editor, you can see that this is just a flat 2D UI canvas. There's no difference in the Z space on any of these objects, and they're simply rendered in the order they are in the hierarchy. Now I'm going to go ahead and start a scene from scratch that kind of will lead you through this whole process that I just went through to build this. Now, of course, I've already done this, so some of these things I don't have to search for any of the functionality, but I can't say that this is something I was able to do with one pass. This took me a little bit of research, and I think just about every project will take a little bit of research. Some projects, as you get more experience, may not take a lot of research. Some projects will. It depends on what you're trying to get done. So I'm going to go ahead and name this video calculator tutorial. And I'm going to put it in my Unity tutorials calculator directory. Here, Unity gives you the option of, this is the first screen you get when you start Unity, by the way. But Unity gives you the option of selecting 2D or 3D on startup. I generally start with 3D. I never really pick 2D, but since I'm making a calculator right now, I'm going to go ahead and pick the 2D setup. I'm going to move this screen out of the way. And now you see Unity gives you a basic empty project. Empty projects can often seem quite daunting because you don't know where to start. So first, I'm going to go through just a quick overview of some of the important aspects of the Unity interface. I'd say the most important aspect is this scene window. The scene window gives you a view on everything that's in your scene. Now, Unity works based on scenes. You can have many different scenes in your project, and each scene can contain a lot of different content. And then you can load those scenes progressively, or you can load and unload scenes, or you can just use one scene. A lot of the projects that I work on only have one scene, and they load content in or dynamically instance prefabs. And you may not know what all that means right now. I'm assuming that people watching this will be beginners. But if you're not a beginner, then you might know some of this stuff, and you might be able to fast forward through some of this video. Anyway, I'm going to try and keep this to half an hour. If I go over, well, then I go over. But I'll try and keep it to half an hour, and I'll try and explain as best I can as I'm working. I might go through a little fast in some parts. Certainly feel free to leave me comments or send me an email if you want more information. I'm more than happy to try and help people get up to speed and learn what they want to learn to do with Unity. Okay, so just like every program, you've got your list of drop downs up here. I'm going to let you explore these on your own, but they're pretty self-explanatory. There's some things in here that you might use on a more regular basis. Build settings, build and run. Clearly save, new scene, all that kind of stuff. It's pretty common. This Windows tab kind of helps you open different windows that you might need. I use the profiler sometimes. The profiler is a nice tool that lets you see how your project is doing, whether it's eating up all the RAM, whether it's graphics card, CPU intensive or GPU intensive. So you can see all sorts of things happening here. And really right now, as a beginner, this is not really something you need to dive into. But anyway, so there are plenty of things up here to look at, and I encourage you as a beginner or even as a novice, to go up here and explore this area. And this all can be extended with Unity editor scripts. But again, this tutorial is not going to go into that. So the next really important thing here is this toolbar here. You've got 5 buttons. Each button does something different. So you've got the scrub, which lets you, pan, lets you pan around your 3D scene. You've got the transform tool, which lets you move objects. So I'm moving this camera that has a really long viewport here. So it looks kind of weird. It has the clipping plane is set to 1000, but its size is only 5. Anyways, just to make this simpler, I'm going to throw a cube in the scene. And you can see I threw a cube in by right-clicking and just hitting the 3D object cube button here. And then I'm going to zoom in on the cube by hitting F in the scene view. I hit F on my keyboard. I like using my keyboard. Alt and left click lets you rotate around an object. Right click does this, rotates the camera around. Middle click, if you have a mouse with 3 buttons, pans. And then F again centers you, so if you're really far away from your object, F will bring it back. So then you've got this transform tool, so you can move objects around. And you can see you have a transform gizmo, so you can see which axis you're moving on. You can lock it to 1 axis. You can grab 2 axes. And then you can go up here and you can rotate. Now you can rotate on all axes. There you go. You can rotate on 1 just like you can with the transform tool. And of course Control Z undoes everything. So you can rotate. That's kind of nice. Then you've got this scale tool. So this is if you're a 3D modeler, 3D animator, anything that works with a 3D package, then some of these things will seem very familiar. You got your non-uniform scaling, uniform scaling in the middle, and then you have this inspector panel over here where you can edit these things as well. Now this last tool here, this is a tool that was built for the 2D system, I believe, more than anything else, but it does work on just about every object. But you can see I can grab handles here. I have a little bit more of a visual gizmo to modify my objects, and it kind of switches depending on how I'm viewing an object. So that's kind of nice. The other nice thing about this toolbar up here is that they all correlate to keyboard shortcuts. So Q is pan, W is transform, E is rotate, R is scale, and T, I'm not sure exactly what this stands for. Sometimes if you just mouse over a button, well, it doesn't really tell you here. But T does a lot of things. Transform, translates, it scales, does all sorts of things. So, okay, so that's that toolbar there. The next thing you have is this little toolbar here. It lets you modify an object from its global or local position. So this object is at 0, 0. If I were to move it to 0, 0, -1, then its local position is actually 0, 0 it's actually from the camera. This is its local position. Its global position would be 0, 0, -1. Now this may not make sense right now, but basically the thing to be aware of is that every object has a global or world position and then a local position. So its position depends on its membership in a hierarchy. If it's transformed from the hierarchy, then its local position would be subtracted from its parent. And so you just have everything zeroed out, and you have whatever the parent's transform is plus that object's transform, or minus that object. So you can see it's 0, 0, 0, -1, whereas the main camera is 0, 0, -10. So this object is really 0, 0, -11. Anyway, that's not that important to know right now, but it is helpful in the future if you work with 3D games, or even complex 3D interactives. Doesn't necessarily have to be games. The pivot point clearly is the pivot point of the object that you're working with. If you select multiple objects, I think you can change the pivot point center, the pivot. So this one is the center pivot for the parent in the hierarchy. This one is the pivot for the child in the hierarchy. And you can see I can rotate around this guy's pivot. If I change it back to pivot, then I'm rotating around the camera's pivot. Anyway, these are things you can explore, as I said, on your own time in the future, and I'll probably go over it in other tutorials when I do something related to 3D stuff. So, okay, so there we have the scene view. The scene view also has this nice drop down that lets you look at objects in shaded wireframe, shaded wireframe. So if I drop another 3D object here, let's drop a sphere. You can see the sphere using F. I'm zooming into it, Alt and left click. I can pan around it. I can look at it in the wireframe view, the shaded view, shaded wireframe. And then there are other kind of drop downs that or options that give you more interesting information here. This would be the alpha channel. If there's any overdraw, if there's another object over here, so you can see the red, kind of red, the dark red gives you an idea of what's being overdrawn. Let me turn off this shaded. I don't know if you can see that in overdraw. You can see when it overdraws, you can see dark red. Mint maps. So as you get farther and closer away, objects maps can be, you can have Unity auto generate mint maps so that the texture maps, they update to lower res versions as you pull away, so they're not trying to render versions that really can't be rendered their full resolution. Again, I think I'm getting a little in the weeds here. This is not really important for what we're going to do here. So I'm going to go ahead and talk about the camera. So as a scene that has a calculator in it, and it's going to be all 2D, we're not going to use a 3D camera. So we're going to use an orthographic camera. This is a 2D projection camera. It basically gives you a box plane. Now, I'm going to assume that we're going to be making it interactive for an HD resolution screen, which is 1920 by 1080, so 1920 pixels wide by 1080 pixels high. So this is my game window, by the way, and I'll park this over here like that. And you can see this is another nice thing about Unity is that you can grab your windows and you can drag them anywhere you want. You can kind of dock them in any way that's convenient to you. And once you've done that, Unity will save that preset or that layout automatically, but you can also save it in the layouts drop down on the top right, which is kind of nice so that you can pull it up with other projects. If somebody saves their project with a layout that you don't normally use, it might load a default layout if you don't have it, or it might try to load their layout if they did send it to you. And you might want to use your own. And of course, Unity has some default layouts that you can also use, which sometimes these can be kind of nice. I usually just stick with my own. I like having the hierarchy menu right next to the inspector panel in case I need to drop objects into slots in the inspector panel, and we'll see a little bit about that later. Finally, so I didn't really discuss the inspector panel. This inspector panel gives you all the information related to any object that you have selected. So if the object lives in 3D or 2D space, it has a transform or a rect transform. So all objects have this transform or rect transform. They live somewhere in 3D space. This object, which is a cube, just happens to have a cube mesh filter, and it has a cube model assigned to the cube mesh filter. Then it has a box collider, assuming that we might use this in a physics system, or we might use the box collider to check for collisions and just have custom reactions. It also has the mesh renderer, so it can render the mesh that's defined here, and then finally it has a default material, and you can create your own material and drop it in the slot. All objects in Unity, game objects, basically they're at their core they have this transform. Unity goes through and finds anything else that's attached to an object and runs a script. So these are all scripts that are components that are run on top of the transform. So Unity will run through in its update loop, find all objects in your scene, and then find all their components and run their update loop as part of its update loop. So the game engine has an update loop, and it's running through every object running their update loops or whatever lifecycle method that needs to run at any given time, whether the object is being closed or activated or deactivated or destroyed. You can have methods that run when certain things happen on your game objects. Just as an example, I can get rid of all this cube component, and then suddenly we have an empty game object. You can see this is no longer a cube. There's nothing rendering here. There's nothing displaying on the screen. There's just nothing here. So this is an empty game object. It's like it's just basically a label that lives in 3D space. And I can add anything I want here. I can make this a 2D image object. And now it's a 2D image object. It's not rendering because 2D images require a canvas. Whoops. So this is what we're going to look at a little later, but I have this canvas. I made the cube a canvas element or an image. So now you can see it's right there. Now it's a 2D image. We're actually looking at this backwards here. So now it's a 2D image in my 3D space. It's actually 2D space because I have a game object or my camera set to orthographic, and canvas is a 2D system. Okay, so I'm going to go ahead and just kind of start from scratch here. So the project window down here is where I would start. So the project window manages all of your assets, your scripts, graphics, audio, anything that you have that's going to be part of your project. It's going to be here in the assets folder. And you can also download data dynamically and add it to your project through a resources directory or an asset bundle. But we're not going to get into that. Then you have your console, which this is used for debugging. This is a really useful window once you start writing scripts. We'll get into a couple of scripts right now. The first thing I'm going to do is I'm going to create a couple directories. I'm going to create a scenes directory. I'm going to create a scripts directory, and I'll leave it at that right now, scenes and scripts, and I'll go ahead and save this. So I'm going to save this in the scenes directory. I'm going to call this calculator. Boom, done. So now you can see there's a calculator scene in here. If I saved another scene, I could modify this hierarchy and then save another scene, and then I could switch between the two and you'd see a difference. Right now we're going to stick with the calculator scene. And the first thing I'm going to do is I'm going to create a UI element. The way I like to create things is by right-clicking the hierarchy panel, going down and finding the appropriate thing I want to create, the appropriate category, and just dropping it in. So I'm going to create, I can create a panel, and this will automatically create a canvas, or I'll create a canvas first, just so you see. This canvas here is an element that's 2D. What it does is tells Unity that we want to render something in 2D, and anything below this canvas is going to render it as part of the 2D canvas system. Canvas has a rect transform, which is a 2D transform element. While it does have a Z position on it, it doesn't necessarily always use it. You can set it to use a 2D or the Z positioning by changing it to world space. Once I change it to world space, you can see the Z position opens up, and this becomes a 2D canvas in 3D space. That may sound confusing, but it's very useful for many different reasons. But again, we're not going to get into that. So I'm going to go ahead and switch to just screen space overlay. This allows you to do pixel perfect, which means that if you make all of your assets in Photoshop, you can bring them into Unity, and you can basically keep everything one-to-one. So all of your pixels are exactly the same in Unity as they are in Photoshop. You don't lose any quality by doing this, or you don't have any strange effects happen when you start resizing windows. So then you could set constant pixel size in this canvas scaler, or you can set scale with screen size or constant physical size. I do scale with screen size usually, and when I set my screen size, I know this is going to be a 1920 by 1080 scene. So I go ahead and do that, and that means that if I drop anything in this scene, so I'm going to go ahead and drop a UI image element, drop it in the scene. Now you can see this, this is actually set to 4K, I'll set this to HD. If I change the size of this screen, it's actually scaling my object up and down. Now this might be more apparent if I scale it up. So I'm going to go ahead and change the size of the screen. You can see it stays the same size relative to the screen size. If I didn't have this scaler set, constant physical size. Now you can see it's not scaling my object. It's keeping it the same size, which makes it a little hard to work with in the editor. But if you were certain that you're going to be at 1920 by 1080 and you had a screen that maybe was a little bigger, you could see everything in the editor at that size and never have to worry about the screen resizing here. But I'm going to go ahead and use scale with screen size. Okay, so this will be my calculator background. We can make this any color we want. This is just an image script, which means it's an image that has a size of 100 by 100. It has a scale of 666, which I'm going to go ahead and change, and I'm going to make this maybe 500 pixels wide by 800 pixels tall. There you go. I'm going to make the background, I don't know, maybe a slight gray, and I'm going to change some of the opacity so it's kind of like a transparent calculator. So that's kind of nice. So now that I have that done, basically the way that the Canvas system works is that I can start dropping in more objects here. I'm going to drop in a button. So they're buttons. They're pre-made. They have this on-click event associated with them. And you can basically add a script into this slot here after hitting the plus. And then you can pull down and tell it to execute a function every time this button's pressed. But the first thing I want to do with this button, I want to give it an interesting look, or you know, maybe not interesting. None of it's going to be all that interesting, but I'm going to at least try and design it somewhat. So I'm going to go ahead and make it 100 by 100 pixels, and align it to the left, and this will be my one button. And I'll go ahead and drop one into the text. So a button is a component that has an image, it has a button script, and then below it, it always creates a text component on a new object. So this text, because it's a separate object, it can be offset, it can be put anywhere you want, but it automatically comes aligned to the button component. Unfortunately, Unity has some strange issues going on with the rendering of text in the editor here. You can see it's rendering fine in the game window. There are other components out there, assets that you can buy, like Text Mesh Pro, which is really nice in terms of getting text in your game and making sure it stays at a really high quality. I highly recommend Text Mesh Pro. I use it in just about every project I work with. But I'm not going to get into that right now. So this will be my first button. I'll rename it by hitting F2. Call it 1. So that's my first button. Now, before I go ahead and make a bunch of buttons, I'm going to make a script here. I want to make this really simple. So I'm going to go and select the scripts directory, right-click on the right side there, go up to Create, go to C# Script. I'm going to call this Calculator. I'm going to go ahead and double-click on the calculator, and this will open Visual Studio. Okay, so we've got Visual Studio open. You can see Visual Studio creates a class. If you don't know what a class is, don't worry about it. Not important right now, but the class is called Calculator. The class, this semicolon here, means that this class, Calculator, is derived from this MonoBehavior class. And if you just roll over things, you can kind of see their descriptions about that. MonoBehavior is the base class every script derives from. So Calculator is derived from MonoBehavior, which means that Unity knows how to call this script and execute its lifetime methods, or its lifecycle methods. So start is one of the lifecycle methods. There are two things that happen when Unity first starts. There's an awake method that's called on a script. I could add that. Let's say void awake, and here I can say debug log. Debug log is a nice way to get information into the control panel. Calculator just woke up. Now this awake method is usually called to initialize. You can see it brings this comment in automatically for you. Use this for initialization. Well, maybe that wasn't for the awake method, but nonetheless, you can use awake to initialize a component. Debug logs calculator just started. So it just started its day. And then if I put a debug log in here, you'll see I'm going to spam my console window. Calculator is updating. So I'm going to spam my console window like this, because when you hit play on Unity, it starts a loop and it never ends that loop. So it just keeps playing that loop. First thing it does is calls all the awake and the start methods, and then it calls update on every object that's in the scene that's active. So I'm going to go ahead and drop an object in here. I'm going to make it empty, and I'm going to call it calculator. I'll put it up here just to keep it in the canvas. You know what, just for the heck of it, I'm going to call this a calculator canvas. Calculator canvas. So now we have our calculator object. I'm going to drop our calculator script on it. I'm going to go open the console. I like clearing the log usually. I'm going to hit play. Boom. Now you can see it's just spamming this console window. There are 200, 300, 400. Just got tons of comments in here. So I'm going to go all the way to the top, and you can see calculator just woke up, calculator just started, and then calculator is updating, and it just says updating, updating constantly. So this is how a game engine works in general. Game engines basically start a game loop, and they continue to execute things in the game loop. Sometimes when you pause things, they just don't execute the update for a game until you unpause them. You know, depending on how it works, and lots of game engines work in different ways, and you can certainly change the way that you pause something in Unity. If you're using a physics system, you would just pause time. If you're using your own kind of update loop, or if you're just using a Unity update loop, then you might have flags, or you might have properties or states for objects, and you check in the update loop. If the objects are set to those states, then you don't update them. Anyways, that's above and beyond again. But you can see the basic functionality of this calculator script and how it's called in its life cycle here. So we are not going to use most of these things. We're going to develop this calculator kind of like a Windows application, which is going to be more event-driven, which Unity doesn't lend itself well to making event-driven applications, because Unity is always trying to update the window, whereas a Windows application just tries to update any portion of the window that gets dirty. So it spends a lot fewer resources updating an application like Word or the calculator application. You know, the calculator application basically doesn't do anything until it receives an event, whether it's a mouse over event, whether you're adding a number or whatever you're doing. It doesn't necessarily do anything to the screen until it receives an event that something changed, and then it just updates that portion of the screen. Unity is constantly updating the entire screen. The the UI system tries to update portions of the screen, but it's still a 3D engine, and it's still trying to update everything else in the scene. So it's not the most efficient tool to use for something like a calculator, although you can create a calculator and you can drop it into your game. So if somebody needed a 2D calculator attached to the wrist of a character, or attached to some object as a texture, then you can make a 2D calculator and you can drop it in. It can be part of a 3D game. Anyways, let's go beyond again. Okay, so now we have our calculator, we've got our script, we've got our calculator background, we've got our number 1 button. Well, we want to know how we can sense when somebody touches this number 1 button. So if I hit play right now, and this I encourage you to do often, is just hit play as often as you can, just to check your scene, make sure your project's working, that your console logs are pouring the right information out. Hopefully not spamming the console log like I'm doing right now. But once you kind of get through that, you got everything set up, you do want to check and make sure that play works. A lot of times if you've written your code and it's not really, it's got errors, or the logic is wrong, then you'll see it immediately in your game here that something doesn't work. So anyway, so this one has an on-click method on it. You can see that the one responds when I click on it already, because this button script has some functionality for clicks. It changes the colors, and you can change all of these properties to make your click look more interesting. I'm not going to do that. But I can drop an object here in this slot. which we have an object with a script on it called calculator. So I'm going to drop my calculator object here. And you can see there are no functions here. I can go down here to calculator, which is the class that we created, and I can look for a function. There's no function in here. So what I can do is I can create a function in here. I'll call it, I'll make it a public method. Function and method are kind of the same term. A method is a class. It's basically a set of instructions in a class that can be called by a name. So I'm going to make this a public method. It's not going to return anything, so that's the second the second property to any function or method. It's whether you're going to return a value when the method is done. And I'm going to call this button pressed. Now this is not the most common way to write a button event handler, but I'm doing it this way because it's a lot less code right now, and we can look at other ways to write an event handler in the future. So let's see here. So one thing that you can do in Unity is you can call the event system, and you'll see that I can't really just call it right now like this because I'm not using the Unity event system namespace. So now that I am using the Unity event systems namespace, by adding this using statement up here, I can call event systems, and you'll see why I'm doing this in a second. Event system current, I want the current event system. I want the currently selected game object. And you can see that Visual Studio is providing me with tips. So now I get the currently selected object, I want its name. So I'm going to just debug log this real quick to see what it returns. Now I've got this one button in here. So I'm going to hit play. I'm going to look down at my log. Nothing's happening. Why is nothing happening? Well, because I didn't hook up the calculator class button pressed method. So now if I do that, one thing to note is that I'm in play mode, and I just changed some properties over here in this inspector panel. Well, that means that when I turn off play mode, these changes are going to disappear. I'm going to go ahead and hit that. You can see all of a sudden Unity is returning a 1. Okay, great. Okay, so that means that I know somebody's pressing the 1. That's fantastic. So maybe what I want here is I want the ability to add a bunch of different buttons. Well, so since I've already created this one, it's already hooked up to this calculator script. I'm going to go ahead and reassign it to the button pressed. I'm going to save this just so I don't lose it. Control S to save. Now I'm going to go over here and I'm going to duplicate this 1. 1, 2. I'm going to call this button 2. I'm going to call this button 3. 4, 3. So I'm going to move button 2 over. And now if I hit T to move something, you can see it starts giving me these alignment tools, which are really nice. So I'm going to use T to move things from now on. Keep T pressed. Or I'm not keeping it pressed, but I'm just going to leave it in that state. And hopefully it will align 150. So I'm going to name this. So I'm going to go back down. I'm going to change the text string in the button. So this is a 3. This one is a 2. Okay, so I've got these 3 buttons. I'm going to duplicate them by hitting Control D. You can also right click on them and go to the duplicate. Now I'm going to move them down. Oops. I just want to move them down. So if I hit Shift, it'll lock it on an axis. Boom. So now this is going to be 4. This is going to be 5. This is going to be 6. So I'm going to get in here, change this to 4, change this to 5, this to 6. Okay. Now, ultimately, we'd want to create these dynamically instead of doing this all by hand. But again, for the tutorial's sake, I'm just doing this by hand, so you can get a feel for the editor, so you can get a feel for how things are set up. And then once you get a better feel for these things, I think you'll start to understand how to do more interesting things by script. So there we go. Get that. So now let's go ahead and change the text on these, and I'll try and zoom through these without talking too much. Okay, I think we're good. Okay, the other thing we're going to need is a plus, a minus. Let's just do plus and minus for this tutorial here. So we want 9 and 7. We're going to duplicate those. We'll bring those two down. 9 will actually be plus. 7 will be minus. Oops, I don't want to have an enter in there. 2, that's going to be plus. F2, that's going to be minus. Okay. So we need one more button. Unfortunately, I didn't leave a whole lot of space. So I'm going to try and move this all up. And I'm going to add the submit or the equals button. Let's do that right there. Make this the equals button. Go down here, change the text field. Equals. Okay. So we have an equals button. Isn't really aligned all that well. CD. Okay. All right, so the last thing we're going to add is an input field, just so you can see what's going on. So I'm going to go ahead and just make one of these buttons, input field, and a nice way to do this is to delete the button script. We don't need a button on this. So now we have this, I'll call it input field. And it has a little text field under there. Now our calculator will want to take any button that you press and update the text field with that button, so that if you hit 1, 2, 3, it shows up here. And then we want to know if you hit plus or minus, it has to show up with 1 plus, and then you hit 3, 1 plus 3, and then you hit the equals. And it could either say 1 plus 3 equals and then the result, or it could just flip to the result, depending on how you want to do it. Of course, you can make this any way you want. But just for the sake of this, I'm going to try and make this quick here, because we're already 38 minutes in. Wow. Okay, so stop fumbling around with that. So let's go ahead and add a field to our calculator that we can access externally or in our editor. So we want to use the Unity text. So you can see I'm going to add a field, and I have to, in Unity, well, in C#, in order to add a field or add a property to your class, well, this is going to be a field in my class. You have to start off with the type of object or the type of element your field is going to be. In this case, our field is going to be a text element. It's really a text class, and you can do a deeper dive on these things, and I can teach you how to do that later. But this is going to be a text class. I'm going to call this the input field, and I'm just going to go and hit save. Now you can see I've updated the script, and nothing has happened up here. Well, there are two reasons, or there are two ways that I could fix that. One is I can make this a serialized field. Once I save that and I look here, it's going to recompile, and now you see there's an input field here. Another way I could do this is I could make this a public field. Remove that, and you can see it's still here. So I find it better to make a serialized field unless you really need to access this text input field outside of this class. In this case, we don't need to do that from another class, not from the inspector, but from another class. And in this case, we're not going to do that, so it's not important. If you did need to do that, You could either make this public, or you could add a getter setter property, which then could modify this, and this could be private. But again, that's a topic for another day. So here we go. We've got our field. I'm going to drag in my text field, and now these two are linked. So I've set a reference to my text field in my input field. Now, just really quick, we know that we get a string from this input event system. We're getting a string. This is button value. We're going to set it equal to that, and then we're going to call our input field, and we're going to set its text equal to button value. Okay, so now let's go ahead and let that compile. You can see down at the bottom right, every time you pop into Unity after modifying a script, it has a little wheel. Once that wheel finishes, it means that you can run your project. So now I can go ahead and hit any number, any symbol, and I get that in the input field up here. If you wanted to save every button that was hit, so some kind of history, you want to define this outside of your method. So I could define, again, a new field, button value. Maybe you don't want to call this button value. Maybe you want to call this input value or input string. And then you could say input string. And actually, I'm capitalizing these things. I'm not sure why I'm doing that. It's best practice to make fields that aren't public lowercase or camel case, or basically they always start with a lowercase character, and then any new word in the variable has an uppercase. So I'm going to go ahead and input string plus equals button value. So let's see. Let's go ahead and play on that. Well, that's 6. No, nothing's happening there, but you can see I have an error here. It says null reference exception. I wonder why I'm getting that exception. It's interesting. When I click on this, if I didn't have calculator selected, is it going to select calculator there? No, it's not, but it is saying input field is null. That's interesting. So it says here, null reference exception, object reference not set to an instance of an object, on calculator button pressed at calculator line 21. And if I double click it, it'll take me to line 21, which is this one. So I have a null reference to this input field. If I go back here and I go to my calculator script, you can see that my input field is empty. I must have assigned it while I was in play mode. Again, I'm in play mode right now. Let me turn off play mode. Let me assign this text field here. Let me go back to play mode. 6, 5, 4, 3, 2, 1. Well, that's interesting. It is still just displaying the text up there. The reason it's doing that is because I still have my input field text equal to my button value, not my input string. So I'm going to go ahead and change that, set it to my input string. I'm going to save it, come back in here, let it compile, and then hit play. 1, 2, 3, 4. Well, look at that. I signed these backwards. 6, 5, 4, 7, 8, 9, minus 0 plus equals. That's everything. And if I keep going, it does have a history of everything in there, but you can't see it all. So if I go in here, you can see I'm still adding characters. All right, now real quick, let's see. So now we've got this going on. This is kind of nice. It is starting to look like a calculator. I do really have to update this 4, 5, 6. You can see 4. So my problem isn't that I have them set in the wrong place, but I just have them assigned wrong. So that's 4, that's 5, and that's 6. I can rename this 6, rename this to 4, and just for keeping this consistent, I'm going to move that up there, and I'm going to move that down there. Okay. So there we go. I'm going to hit save just to keep this project updated. in case Unity crashes. Unity does like to crash every once in a while. Okay, so back to our script. Now I can start acting on this data now that I know I have it. The first thing I'd want to do is I want to find out whether the input that's coming in is an integer. So I'm going to go ahead and get the button value and set it to an int. So the int data type is the data type that stores any whole number, negative or positive. And in Unity, well, in C#, you can perform functions on anything that comes in and try and convert that data that's coming in to an integer. So I basically called the class, and there's a set of static methods here that I can call. So int try parse is one of the methods that you can use to try and parse an object or an incoming string into an integer. So I'm going to go ahead and use this one, try parse. Because try parse returns a Boolean value. So if you look over here, try parse returns a Boolean value. You give it a string, and then you give it a result. So I'm going to go ahead and type in try parse. I'm going to give it a string, which is button value. I'm going to say int value, or I can say arg. So now arg isn't defined, so I'm going to define arg here. And I'm going to say out arg. So if it successfully parses our button value into an integer, then I'm going to perform some kind of operation on it. Or I'm going to save it. That's what I'm going to do. I'm going to go ahead and save it. So in order to save it, we're going to need what's called an array, which is basically a variable that stores multiple variables. So the way we define an array of integers is like this. We do integer or int, and then open close bracket. This is numbers, equals new int. So new int allocates space for this integer array, and we're only going to allocate 2 spaces. So I'm going to assume that we're just going to do arithmetic on 2 numbers, and they're going to be single-digit numbers. As you get more complicated, you learn more programming techniques, feel free, or if you already know them, feel free to make this calculator as fancy as you want. I'm also going to make a string for our operator symbol. Call this operator, again, lowercase operator symbol. So if we're successfully parsing this to an integer, I'm going to store this number, our integer, into our array here. Now, interestingly enough, here we don't. When you call an array, you give it a script. You give it a number, so which refers to the slot in the array. So this is, and it's 0 based. The first slot is number 0. The second slot would be number 1. If I had more than 2 objects in here, I could number 2, number 3. I could keep going. In this case, since we only have 2, I'm going to set. I could set the first one to the number and say we're done there. But now the second number that comes in is also going to be set to 0. I don't want that to happen. So I'm going to define another integer. I'm going to call this I. I'm going to set it to 0. And then here, I'm going to check if I is greater than 1, then I equals 0. And then down here, I'm going to increment I. So I plus plus increments it. I plus equals 1 will add 1 to I, or I equals I plus 1. All of these statements are basically the same. So I equals I plus 1, increments it. I'll leave it like that just for simplicity's sake, in case anybody gets confused with the other methods here. So now I'm going to change this to I. So the first time you press a button, it's going to come in and it's going to say, is it an integer? If it is, store it in this arg integer variable. And then come down here, check if I is greater than 1. If I is greater than 1, set it to 0, then set number slot 0 to the number, or set number slot 1 to the number, and then increment I. And then it'll continue going down here. So now we have number I. We have our numbers stored. Now we also need to know if integer doesn't parse our argument or a button value, then we have to do something else because we're clearly trying to either set an operator or tell this method that we want to get the arithmetic results. So button value, I'm going to perform a switch on the button value. If the button value is plus, then our operator symbol equals plus, right? Well, we can just set it equals button value. Break out of this. If our operator is a minus, then operator symbol equals button value. And really, you can see these two things do the same thing. So maybe there's a way to simplify that. If our operator is an equals, and we don't want to set our operator symbol to anything. What we want to do is get the results. So we'll set results equal to number 0. We'll do number 0. Well, so here we could do another switch if we're doing. So this is going to get a little complicated, but here I'll do another switch, and we'll switch on our operator symbol. So we'll switch here. We'll say, is the case plus? If it is, then our result will be our result. Because I haven't defined result as a variable, then Visual Studio doesn't know exactly what to return to me. Our result will be number 0 plus number 1 break. I'm going to go ahead and define result up here as an integer result. So then our next case is a subtraction. Result equals number 0 minus number 1 break. And then break. And actually, we don't want to break yet. What we do want to do is we want to set our input field to our input string. Our input string could be button value, could be plus button value, and then if result isn't empty, we could also add string equals result is not equal, or result equals nothing. Or I guess we can do, well, I'll say nothing for now. Result equals nothing. Then does not equal nothing, then input string plus result. Okay, match that up a bit. Okay, so after the results, then we also want to clear. We want to clear the. We will want numbers equal new int 2. I'm sorry, not numbers, number. So that would reset our numbers. So here, this is plus nothing. So now this is a complicated looking line. The reason I wrote it like this is, well, what this is an if statement, basically. So you can see if an integer, try parse, blah, 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 then this, then do this, else do all this. Well, this is an if statement in one line. So this says if the result is not equal to nothing, or an empty string, then add result to the input string variable, or just return the input string variable. We probably want a space here, maybe an equal sign, plus result. Okay, like I said, it's good to jump in and out and test your project regularly. So let's test this. 1 equals 0. Well, that doesn't look right. That does not look right. So that doesn't look right. Why doesn't it look right? Because it looks like this statement here is confusing. It's confusing Unity. So let's just say, for now, to simplify it, let's actually just set input string to the result. So what we'll do is we'll set input string to the button value first, and then if somebody hits equals, we'll just set input string equals result. So go back here. You can see we have an error. Cannot implicitly convert an integer to a string. So result is an integer, input string is clearly a string. So let's convert this. There's a nice method on integers. If you just hit dot, you get a static method to convert to string. So we'll do that. That'll solve that problem. Now, as you're learning to program in C# and Unity, you will come up with errors quite often, and troubleshooting them is extremely important. So there you go, 7 plus 7 equals 14. Now I didn't clear the input string, so you can see here I didn't clear the text, the input field. So maybe we want to do that after we have displayed the results. So one way we could do that is we could add a boolean. Oops. Add a boolean displayed results equals false. Now after our input field, after we've hit the equals button, so here with the case where we hit the equals button, we just say displayed results equals true, and then the next time we come in here, the first thing we do is check if displayed results equals true. I'm going to write this out. You could just check displayed results, then input field.text equals nothing, or a blank string. There we go. Okay, so 1 plus 3 equals 4. 4 plus 5 equals 9. Okay, you can see there's still an error. So I hit 5 after I got my result, and it didn't clear 9. So I hit stop, we'll come back in here. If displayed results, so now displayed results has to equal false, because we've already reset them. So let's see, is that the error? 2 plus 9 is 11. 0, that's not the error. Plus 9 is 9. So the error here is that our input string equals button value plus equals the button value. Down here, input field equals the input string. So we also need to clear the input string. Input string equals nothing. There we are. Reset everything. 1 plus 5 equals 6. 8 plus 9 equals 17. 3 plus 5 equals 8. Great. 7 minus 8. Negative 1. 7 minus 0. 7. 1 minus 2. All right, great. So you can see this working now. Now you can build this, and you can make your own little application. You can send it off to your friends, and be really proud about a calculator that does basic arithmetic. But anyway, so I hope this gave you a good overview of, first off, the Unity editor and kind of the things that you would need to learn to work with the editor. A little bit about Unity UI system, and a little bit about Unity programming in C#. Now, again, I don't think that anybody has to worry about learning everything we just went through here and memorizing anything. These are things that you can learn with experience, or things that you can research online. You can always pull up the Unity scripting reference, which I highly recommend doing. Unity comes with a lot of great information in their website. So if I just go to Unity 3D, and I can type anything I want, or I can type in reference. You can see the Unity 3D reference comes up as the first thing, scripting API. Click there, and you get all sorts of great things. I want to know what's going on in the Unity engine. I want to do Unity scripting, attributes. There are all sorts of things here. Some classes, interfaces. Interfaces is also a very interesting topic, and we can go over that in the future. But so I'm going to leave it there for now. There's quite a lot to learn in Unity, and you can do tons and tons of things that are really interesting. Kind of the sky's the limit, because it's a 3D engine, and you can basically create your own worlds. You can do whatever you want in this. It's all about your imagination, your will, and kind of sacrificing some frustration at times, but often getting some really interesting results. Like I said, I mean, this thing is a 2D calculator. It's probably not that interesting to most people. I can easily change this to a 3D calculator by setting it to a world space. Well, not 3D, but a calculator that lives in 3D space at the very least. So my main camera, this is something I also didn't talk about, but my main camera is set to 5. I set it to 540. Make sure it's centered. Then my canvas, now that I set it to world space, lives in this 3D camera space, or it lives in my 2D camera space. But since I set it to world space canvas, I can now rotate this thing, and it's clipping through the camera plane. There we go. But I can rotate it. I can do some interesting things, and no matter how I rotate this thing, see, I'll put it back like that. I hit play. Bring this up here. It's bigger. Now I have this rotated camera. This rotated, 2 plus 23 plus something is not 11. 6 plus 9. But now I have a calculator that's rotated, and I can use it in a perspective, which is kind of interesting. So you can maybe start thinking of some really interesting things you could do with the rotations. And again, this is just by setting it to world space. If we go back to screen space, it's set as a flat 2D camera, 2D calculator. Okay, so I'm going to leave it there, and I hope people got something out of this. I look forward to any constructive comments, and certainly send me emails, requests for different tutorials if you want. I'd really like to make more tutorials. I feel like it helps me kind of bake in some of the things that I do on a regular basis, and formalize my terminology, which is something I really need to do. Okay, I'll see you next time. I'm going to try and do one of these tutorials at least once a week, and hopefully get better at them. I'm sure I have plenty to improve upon here.